Today we're going to be discussing solving linear equations in one variable. And what do we mean by this? So a linear equation is any equation where whatever your variable is, at most the operations going on to it are maybe some multiplication or division and some addition or subtraction, and it's an equation, so it's going to be equal to, let's say, some other constant. Or it could be rearranged to look something like this. In particular, if it's going to be in one variable, you shouldn't have two variables floating around. It's still linear, but it's not going to be a linear equation of one variable. And you shouldn't have any other operations floating around, such as exponentiation, no longer a linear equation. Square rooting, no longer a linear equation. Exponentiation, but the x is up in the exponent, still not a linear equation. So it only needs to have, as written kind of more formally here, maybe a number being added maybe a number being multiplied or divided by x. It is okay if the variable is something other than x, and it is okay if that number being multiplied or divided is 1. And then potentially some other number being added or subtracted to x equaling some other number being added or subtracted to x, and it's okay if those other two numbers are 0. That's all this is saying kind of more formally in the beginning here. More importantly, we need to have straight how we solve such equations. So let's go ahead and practice that. As a pro tip, what I sometimes do just to kind of keep things straight here is I will divide up my equation into its two parts. I've got the left-hand side and the right-hand side of the equation that I'm dealing with. And your first step to solve is to simplify within each side of the equation. Once it's simplified, I should simply have an x term and a constant, so I should have at most 4 total terms. In this case, my right-hand side is already simplified, so I'm just going to drop him down. Nothing more to do there. My left-hand side is not yet simplified, and in terms of order to simplify the left-hand side, I personally would strongly recommend first using the distributive property, so there's no more parentheses, then combining like terms within that side of the equal sign. So in particular, I'm first going to deal with distributing. So 3 times x will get me 3x, 3 times negative 2 will get me minus 6, and then I'm otherwise just going to drop down my 11x. Now I'm still combining like terms and simplifying here though, because on the left hand side not all my like terms have been combined yet. In particular, 11x plus 3x is going to get me 14x, and then I'm just going to drop down all other terms. Once I have this down to just an x term plus or minus a constant equals maybe another x term plus or minus a constant, there's no more distribution to do, no more like terms to combine within one side of the equation. I'm good to move on to my next step, which is to move all variables to one side of the equation, because my goal is to get x by itself. So in this case, I'm going to undo adding a negative x by adding a positive x. And what do I mean by undo? I mean that negative x plus positive x makes 0. That's what that canceling out means. And then 14x plus x equals 15x. And then I'm otherwise just going to drop down the rest of my equation as is. Again, at any step, you should not change the value of the equation. You're either just combining like terms within one side of an equal sign, or you're undoing the same operation on both sides. So whatever operation you do on one side, you have to do on the other side to keep your equation balanced. Next thing I'll want to do is go ahead and move all constants to one side of the equation. So in a similar move, I'm going to undo subtracting 6 by adding 6 to both sides, because negative 6 plus 6 makes 0. And now I'm left with 10 is equal to 15x. Now I'm ready to actually get the variable by itself. Once I just have some number being multiplied or divided by a variable equals a constant, now I'm ready to go ahead and just undo any multiplication with division or undo any division with multiplication. So in this case, I'm going to undo multiplying by 15 by dividing both sides by 15, since 15 divided by 15 makes 1. And then I'm left with x is equal to, and then 10/15 does actually simplify. In particular, both the top and the bottom are divisible by 5. 10 divided by 5 leaves us with 2. And then 15 divided by 5 leaves us with 3. And then I have my final answer of x is equal to positive 2/3. Now what you should also be in the habit of doing is double checking your solution by plugging it into the original. So you would want to double check, for example, that 11 times positive 2/3 plus 3 times 2/3 minus 2 is actually equal to negative 2/3 plus 4, utilizing order of operations on both sides. Now in this particular case, I probably would use a calculator strategically to actually check this, but I would do it in order of operations. So I'd first do the negative 2/3 minus 2, then multiply by that by the 3, record that as a fraction, then do 11 times 2/3, record that as a fraction, add up the result, and then see if that's the same thing as negative 2/3 plus 4, and it should be. Now there are special cases that can come up as well. In particular, if you had something along the lines of 5x is equal to 5x plus 1. Well, if you start solving this with these steps, what you would do is undo adding 5x by subtracting 5x on both sides, because your goal would be to move all the 5x's to the same side. And then you would discover, oh, I've just left with 0 is equal to 1. That doesn't make sense. That would be the case of no real solution, because I would have a false statement at the end. Versus a true statement would be something like along the lines, if I had 4x plus 2 is equal to 4x plus 2, well there, if I try to move all the x's to the same side, I run into the same issue that they eliminate from both sides, and I'm just left with 2 is equal to 2, but that's a true statement. So that would be all real numbers, also known as infinite solutions. So do keep in mind that if all the x's eliminate, that doesn't necessarily mean that you did it wrong, but it does mean that you're in a special case scenario. So I'm going to encourage you to go ahead and pause your video and try out these examples for yourself. My hint is don't freak out if you get fractions as results. Okay, welcome back. Let's go ahead and talk through these two examples. So for this first example, if I have negative 4x plus 16 is equal to negative 12x minus 7, both sides of the equal sign are already simplified, which is nice. My next goal will then be to move all x's to one side, all constants to the other. So in particular, I'm going to choose to undo the negative 12x by adding positive 12x to both sides. Negative 12x plus 12x makes 0, and I'm left with 8x plus 16 is equal to negative 7. Then I'm going to want to move all constants to the same side, so I'm going to undo adding 16 by subtracting 16 from both sides. And then I'm left with 8x is equal to negative 23. Now I'm ready to get x entirely alone, so I want to undo this multiplication by 8 that's going on. So I will divide by 8 on both sides. And then I will be left with x is equal to negative 23/8 as my final answer. And if you do indeed plug that back in, you will find that you get a true statement and that both sides are equal to each other. For the next one, it's not quite simplified yet, although it's close. I have no distribution I got to worry about. However, I do have these like terms within the same side of the equal sign, in particular the 11x plus 9x. I'm going to go ahead and combine these like terms to make 20x, drop down the minus 29, equals negative x plus 4. Then I'm going to go ahead and move all x's to one side, all numbers to the other. In particular here, I'm going to add x to both sides. 20x plus x is going to leave me with 21x. 1 minus 29 equals 4. Then again, my goal is to get x by itself, so I'm going to want to move all my constants to the same side. So I want to undo negative 29 by adding 29 to both sides. And I'll be left with 21x is equal to 33. And as a final step, I will divide both sides by 21. And then I'll be left with x is equal to 33/21. Again, it is actually a correct solution. If you do plug it in, you will find that this is a true statement. And if you're in the habit right now of always thinking, oh, I got a fraction, that means I did it wrong, not necessarily true. Just still check yourself, and maybe if the fraction is messy enough, don't be afraid to check yourself kind of carefully with the calculator, save yourself a little bit of time. Now, as a pro tip with parentheses, I lied a little bit before when I said you had to distribute. It's a good habit to get into, but there's technically two different methods you can do. Because keep in mind that number in front of the parentheses, that actually is multiplication. So you have two different options. You can distribute them, which you're probably in the habit of, or technically you can divide both sides by that number as well. There's two examples written out here, but be careful about this second method, because if, for example, you had 4 parentheses x minus 3 plus 16 is equal to 12, when you divide both sides by 4, there's something I just did wrong here. You also need to divide that other term that's being added there. And so it's really considered sort of that this is a term, this is another term, and actually and that's another term. So you need to divide all 3 of those terms by that 4. That's a step that people often forget, which is why being in the habit of distribution is probably a little bit of a safer bet. But technically, this is still correct math as well, that will still lead you to the same result as just being in the habit of distributing and simplifying each side. So there is more than one way to go about such problems. And then again, combining like terms within one side of an equal sign, always a good habit. That I would subtract 4 from both sides to get x's too. So you can get the same solution either way, and occasionally it is actually simpler to divide both sides by the number in front of the parentheses, so keep in mind that it is actually an okay method. You're still undoing multiplication with division. Or if you just want to be always in the habit of distributing, that will always work, but you really have 2 choices on how you want to approach that. Similarly, you also do technically have 2 choices for dealing with fractions. You can, if you're really, really comfortable with fraction operations, then you would say, oh, well, 2x over 5, that's the same thing as x times 2/5. I will undo that by dividing both sides by 2/5. Then whenever you have dividing both sides by 2/5, you would use your knowledge of fraction division to say, okay, that means keep the first number the same, change division to multiplication, and then we're going to flip the last number, so we're going to change this to multiplying by his reciprocal. Then you'll multiply across the top, multiply across the bottom, so multiply your numerators, multiply your denominators to get a final answer that simplifies down to 15, since 30 divided by 2 is 15. If you're not as comfortable with that, it's totally fine to do this in 2 steps instead. So if you had something like 2x over 5 is equal to 6, what you could do instead is multiply both sides by a number that would essentially clear all denominators, or kind of more formally, multiplying both sides by the least common denominator. So in this case, 2x over 5 equals 6. 6 is secretly over 1. Their least common denominator is 5. 5 divided by 5 makes 1, so that's why that cancels. I'm left with 2x is 30, and then I would divide both sides by 2 to undo multiplying by 2 to get that x is 15. If you notice, I still did the same operations both sides. So either of these are completely okay methods. Typically, if you're not as comfortable yet with fractions, method 2 is usually a good way to sort of systematically deal with it very reliably. But as you get more comfortable with fractions, you'll probably find yourself leaning towards method 1. But they really are the same math either way. So I'm going to go ahead and pause, and I want you to go ahead and take a moment to try this. So pause your video and then come back and compare results. So here, my left-hand side is already simplified. It's just a 45. I'm just going to drop them down, leave them as is. My right-hand side is not simplified yet, though. And whenever I have this minus 6 in front of parentheses, I would go ahead and change that to plus a negative, because that's really what you're doing. So you're distributing negative 6 to negative 2, and negative 6 to negative 5w. So I'm going to drop down the 31. Negative 6 times negative 2 gets me plus 12. Negative 6 times negative 5w gets me plus 30w. So keep in mind that that negative is really attached to the 6 whenever you're doing that distribution. Then I want to identify any like terms within one side of an equal sign. In particular, 31 plus 12, that's going to get me 43. I'm going to drop down all my other terms here. Then again, my goal is to get W by itself. So I'm going to undo any addition subtraction that's going on so that I can move all constants to one side. So I will subtract 43 on both sides. And then I'll be left with 2 is equal to 30W. And then as a final step, I will be dividing by 30. Notice how I don't automatically divide by the smaller number. I automatically divide by whatever is being multiplied by the variable I want to get by himself, which in this case is W. 2 over 30 does actually simplify a little bit because both the numerator and denominator are divisible by 2. To be left with 1/15 is equal to W. And again, don't be afraid of fractional results. They happen sometimes. Go ahead and try this next one yourself, and then we'll come back together and compare it. Okay, so for this next one, again, I'm going to go ahead and simplify each side of the equal sign. This is one that I think is good to sort of visually separate the two, because my goal is to make it where there's only 4 total terms, and I obviously have more than that right now. So I'm going to go ahead and just do one step at a time. What I'm going to choose to do is distribution here. So I'm going to go ahead and distribute on both sides here. So if I distribute, -3 times positive 2y gets me minus -6y, or plus a -6y, or minus positive 6y. Either way, I realized I accidentally said double minus there. -3 times 9 is going to get us minus 27. And then I'm going to just drop down the other 3y. I'm going to do the same deal on this other side, so I'm going to drop down the 3. -9 times -9 gets me plus 81. -9 times -y will give me plus 9y. Now I want to identify like terms within each side of the equal sign. So in particular, I see -3y minus 6y. That's going to get us -9y. I'm going to drop down the 27. 3 plus 81, that's going to get me 84. And then I'm going to drop down the positive 9y. Now my goal is to move all variables to one side, all constants to the other. I'm going to go ahead and just choose to move my y's to the left-hand side. It doesn't technically matter. So I'm going to undo adding positive 9y by subtracting 9y on both sides. Positive 9y minus 9y makes 0. -18y minus 27 is equal to 84. Then I'm going to want to undo subtracting 27, so I'm going to add 27 to both sides. Draw that up here, so we have -18y is equal to 4 plus 7 is going to get us 11, carry the 1, so that'd be 111. Then as a last step, we're going to divide by -18. So I'd be left with y is equal to -111 divided by 18. And I don't believe that simplifies. Actually, maybe it does simplify. And how do I know maybe it does simplify? Well, in particular, I know that the divisibility rules for 3 is that if the integers in the number add up to a multiple of 3, then it's divisible by 3. So in particular, 1 plus 1 plus 1 is 3. So I know 111 is actually divisible by 3, and 18 is divisible by 3. So I'm actually going to go ahead and divide both of these by 3. And that would leave me with -37 over 6 as my final answer for y. And again, fractions can be answers. Don't freak out just because you get a fraction. Let's go ahead and keep going. So for this next one, we've got fractions involved, and we want to think about, okay, we've got 2 different strategies here. Either, in this case, very, very technically, you could distribute that dividing by 5 to both of these terms. Or you can go ahead and clear the fraction. So I'm actually going to go ahead and show you both methods. So we got method number 1, and we've got method number 2. Both totally okay ways of approaching this problem. So I'm just going to rewrite this, and then you can decide which way you think that you would be more consistent solving these. So if you recall, the 2 different methods for fractions is either to clear the fractions or just use inverse operations. I mean, you're going to use inverse operations both ways, but we'll see what we mean here in a second. So for clearing the fractions, I'm going to recognize the 8 currently is secretly over 1. So the smallest number I need to multiply both sides by so that there's nothing left in the denominator besides 1 is 5. 5 is my least common denominator. 5 divided by 5 makes 1. So that would cancel out, so to speak, because of that. And I'd be left with 2x minus 6 is equal to 8 times 5 is 40. And then I can go ahead and solve this way that I've been solving. So I've already moved all x's to one side. Now I've already done a distribution, simplification, that sort of thing. This is as simplified as it gets. I just need to move all constants to the same side and then undo the multiplication. So I'm going to undo subtracting 6 by adding 6 to both sides. Then I'm left with 2x is equal to 46. And then as a final step, I'm going to divide by 2 on both sides to undo multiplying x by 2 to leave us with x is equal to 23. And this is a good example that I think kind of explicitly showing how you would then plug that back in to check yourself. Because if I plug back in 23, I'd have 2 times 23 minus 6 divided by 5. I want to see if that's equal to 8. Well, 2 times 23 will get us 46. 46 minus 6 gets us 40. And 40 divided by 5 does give us 8. So we know we did the problem right. As an alternative method, since both of these numbers are over the same denominator, technically that means that we can sort of distribute that division. And what do I mean by that? Well, that means that this is the same thing as 2x over 5 minus 6 over 5. Tomato, tomato. I just distributed that division to both of those terms because there's sort of an implied parentheses up here, if you will, by that big old fraction bar. Then I would just kind of directly deal with all of these fraction operations. So I'd probably want to undo subtracting 6/5 by adding 6/5 to both sides. Typo there. And if I currently have an 8, if I want to do 8 plus 6/5, I've got to change 8 to have the same denominator. So I would multiply both the numerator and denominator by 5 to get us 40 over 5. So I'd be left with 2x over 5 is equal to 46 over 5. Then I would undo multiplying by 2/5 by dividing both sides by 2/5. And then I would know that dividing by a fraction is the same thing as multiplying by its reciprocal. And then I would notice that the 5 over 5 part that I have here is going to make 1. And I would be left with 46 over 2, which would be 23. So either way, I still get the same answer. I think most students would probably find method 1 a little bit simpler, but method 2 is also totally fine to do. So with that in mind, pick a method on how you want to personally deal with the fractions to approach these problems. Now I'm going to model the first one again very explicitly, and then I'm going to encourage you to try the second one yourself after maybe I first go through that initial distribution for you. So for the first one, if you just want to kind of clear all the fractions by multiplying by the term that will be that least common denominator. In this case, that would be saying what's the smallest number 8, 5, and 40 go into? That would be 40, in particular since 8 times 5 is 40. So let's kind of break this up by both methods. So if I'm going to do the just kind of clear the fractions method, what I'm going to do is take all three terms, you have to do this importantly to all three terms, and multiply them by 40. So if I do 7/8 times 40, what I would do in particular is actually do the 40 divided by 8 first, and that would get us 5, and then 5 times 7 would give us 35 equals, and I would do a similar method here. I do the 40 divided by 5 first, that would get us 8, times 4 would get us 32. Minus, and then 40 divided by 40, that's going to get us 1, and then we'd have the minus 9 there. And then we're ready to rock and roll with no more fractions left. Or I should say non-trivial fractions. Technically all these numbers are over 1. So I would move all constants I would move all variables to one side, all constants to the other. I'm going to choose to subtract 32 from both sides, since one side currently has just a variable and the other one has just variable and constants. That'll cancel out to make 0. I'll be left with 3x is equal to negative 9. And then as the last step, I would divide both sides by 3. 3 divided by 3 makes 1, and I'm left with x is equal to negative 3 as my final answer. Alternatively, I can also just directly deal with the fractions and directly do fraction operations. So in particular for this one, what I would do is say, okay, I want to move all x's to one side, all variables to one side, keep constants on the other. So I would subtract 4/5 x from both sides. Now if I'm going to be doing 7/8 x minus 4/5 x, just like when I normally deal with fractions, I'm going to have to make sure that these have a common denominator. So I'm going to have to multiply both the numerator and denominator by 5 for the 7/8 to make 40 as their least common denominator. And then I will have to multiply both the numerator and denominator by 8 to make 40 their least common denominator. So then I'd have 35/40 x minus 32/40 x, which would end up with 3/40. Let me make that another line. 3/40 x equaling that negative 9/40. Then I would undo multiplying by 3/40 by dividing both sides by 3/40, keeping in mind that dividing by the fraction is the same thing as multiplying by its reciprocal. To be left with 40 divided by 40 is 1. 9 divided by 3 is negative 3. To be left with x is negative 3. Again, either of these methods are fine. You either want to recap, you either want to, let me do this new color, you either want to clear all denominators by multiplying all terms by the least common denominator, or just deal directly with the fractions and make sure you're doing your fraction operations okay. Either way is fine, and either way will still get you to the right answer. So with that in mind, go ahead and try, let's actually distribute first, and then I'm going to have you try this next one yourself. So for this one, I would recommend going ahead and just actually distributing first. So I would distribute the 5 to the 3/4 x and the 5 to the negative 4. I'm going to drop down the other terms. 5 times 3/4, remember that 5 is secretly over 1. I would do 5 times 3 to get us 15, 1 times 4 to get us 4, minus, and then 5 times 4 is going to get us 20. If you think that, I would go ahead and pause your video and make sure that you can identify the least common denominator, and then we'll go through identifying that least common denominator together. So the least common denominator of all of these terms, again, is the smallest term that all three go into. So the smallest term that 5, 3, and 4 are going to go into is actually going to be 60, the result of multiplying 5 times 3 times 4. How do we know this? Well, 5, 3, and 4 don't go into each other. So the smallest thing that they're all going to go into is just multiplying them all by each other. And then technically the 20 is over 1, so you could sort of note that too, but 1 goes into everything, so it's not really contributing anything interesting. So go ahead and pause your video and try this, and then we'll go over it together. So for this, if I'm going to do the method where I just kind of clear the fractions, which I think might be a good method to approach this here. Let me just rewrite these with a little bit of room. What I want to do is then multiply each of these by that least common denominator. So in this case, that would be 60. So 60 times 1/5 is the same thing as 60 divided by 5. That would leave us with a 12x. 60 times 1/3 is the same thing as 60 divided by 3. That would leave us with a plus 20. For this next one, I would personally do the 60 divided by 4 first. 60 divided by 4 is going to get us 15. And then 15 times 15, I think, is 225, but I'm going to double check myself because I don't know for sure. 5 times 1 is 5, plus 2 is 7. 5 times 1 is 5. 1, 5, 2, carry the 1, 225, yes. 225x minus, and then 60 times 20 is going to get us 1200. Then we're going to want to just keep on going. So here we're going to, again, still want to move all variables to one side, all numbers to the other. So I would subtract 12x in particular in order to get us 213x minus 1200 is equal to 20. Then I would want to add 1200 on both sides to undo subtracting 1200. That would be left with 1220 is equal to 213x. Then I would divide both sides by 213, and then I believe that would be actually as simplified as it gets. It's not the prettiest fraction in the world. But regardless, you could still plug it in, double check it works, especially with a fraction as messy as this. I would strongly recommend sort of plugging it back in by using a calculator. Last but not least, there are some also just practical application problems that you kind of have to know how to navigate. So you might be given a formula, for example, for some real-world application. In this case, we've got a formula for speeding fines, where F is your cost of some for the fine for somebody driving with a certain speed S. And then we're going to actually solve a practical application. So if the fine was 510, how much were you speeding? So we'd want to plug 510 in for the cost, and then otherwise rewrite the equation exactly as is. And I think my S is looking a little bit funny, so I'm actually going to try to stylize it a little bit more. That's still where we've got that variable S. Otherwise, all I did was replace the fine with how much it actually was. Now I'm going to still solve it with all the same techniques I've been doing. So I'm going to undo adding 55 by subtracting 55 on both sides. If I want to do the subtraction by hand, it's kind of a double borrow situation where I've got to borrow 4, borrow 10, but then borrow 1 more from that to make 9. Make that 10. 10 minus 5 is 5. 9 minus 5 is 4. 445. Drop down the 13, S minus 50. And then here, I would want to keep on going dealing with my parentheses, so I would distribute the 13. 445 is equal to 13s minus 13 times 50 is going to get us 650. Then I would add 650 to both sides to undo that subtracting 650, because again my goal is to get the variable by itself. Then I have 13s is equal to 1095. And then as a last step, I would divide both sides by 13. And then I'm just going to, for the sake of time, sort of do that off to the side on a calculator, although you could do that via long division. And you would get either a decimal or fraction number. So that's about 84.23 as a decimal. Or as an exact fraction, I believe this is already simplified as is. Could also have some sort of more practical geometric problem as well. So if you're dealing with a practical geometric problem, if you had some sort of rectangle and you had various, normally the shortest side is actually labeled as a width, isn't it? Width, width, length, length. The perimeter means that you are adding up all of the sides of the rectangle for the total length around. So in particular, the perimeter would be equal to length plus width, or combining like terms, 2 times the length plus 2 times the width. And then if they give you certain pieces of information that the perimeter is 82 centimeters long, so plug that in for perimeter, and the length is 25 centimeters, plug that in for the length. You can plug that in on your diagram as well. And then if you want to find the width, this is now looking a lot more like your typical problems we've been seeing so far. Any sort of just plain simplification in terms of arithmetic you definitely want to do first. So 2 times 25 gets us 50. Then again, my goal is still the same. I want to get my unknown variable, in this case w by itself, so I would subtract 50 from both sides. 82 minus 50 is going to get us 32. And then as a final step, I'm going to divide by 2 on both sides to leave us with 32 divided by 2 is going to get us 16. So my final answer is that my width would be equal to 16, in this case, centimeters.